Now, we're going to be working today on using a TinyDB for this little tutorial video. So we want to go ahead and make a new project for this. And I started off with the history of computing AM project. That was not what we want to work on. So we go ahead and go to new. So go up here, go to new, and this is the TinyDB sample. And a TinyDB is a very specialized, very tiny version of a database. It's a way of storing data inside your Android environment. Now, Android, as its regular storage unit, uses what's I think it's SQLite, so it's the tiny version of SQL. It doesn't have all these same ultra huge powerful features that you get with regular, say for example, MySQL, NoSQL structure. But you have all the major and main database structure components with that. TinyDB is not that nifty. TinyDB is, again, this is a database that can be used by anyone. Again, going on that idea of AppInventor, that anyone can use this. You don't have to know special rules and stuff to do it. So, to do this, we're going to need to get some data. We're going to need to collect data. And so we're doing that. We are going to have a button on here. And we're going to add a couple text boxes. And we can put in there. And we'll put a label on top of each of those just because we can. It makes it make more sense. So we have those basic things. I said it. We have those basic structures for that. We have a name label, name box, a food label, food box, and a movie label, a movie box, and a submit button. And so we're just going to use this to start off right now. We're going to get this ready to go on these very first basic components. We'll go ahead and pop over to Blocks Editor. And in our My Blocks, of course, we have all those components right there we've already seen. But we're also wanting to add to this, we want to add a TinyDB. And of course, TinyDB is non-visible. We can't see it. And so we're going to rename this from TinyDB1, and we'll call this, instead of TinyDB, we'll call this FavoritesDB. So it's our favorites, right, with a name. And we'll go ahead and say OK. And notice how there are no properties over here on the right for our favorites database, or our tiny database object. The properties of the database are not something you specify inside AppInventor. So we'll go ahead and drop back over into our blocks editor. And there's our favorites database. Let's take a look and see what we have in there. We have a method to get value, a method to store value, and we have our database. Yeah, and this is exactly what it's supposed to have. This is not the WebDB. This is the FavoritesDB, or TinyDB, excuse me. That's our FavoritesDB is what we called it. So, what we're going to do is we're going to store things into our TinyDB. And the way we store things in the TinyDB is the StoreValue method. And so if you look at it, it's going to store the given value under the given tag. And this storage, as it says right here, it does persist on the phone after the app is restarted. So that means you can close the app and open it back up and it's still going to be there. So that's kind of cool. This is a way of storing stuff in there. Like when you turn off your app, it's not going to go away. So this is good for you on that purpose, right? So what we're going to do is we're going to go ahead and go to our submit button and submit.click. And when we submit.click, what we want to do is we want to actually get the information that's inside our text boxes, and we're going to add that to the database. What do we need to do? We need to get the text. Okay, so that's a plug. So I can't just plug that right in here. I need something I can store it into. I need something that can hold it. I'm going to go ahead and get my movie text one as well. And it's also the same thing, just like that. And I'm going to get my name text. And so I have these three values that are text. So I need to plug them in my database. Okay, so I have store value. So when I submit my button, I want to store value. What am I going to store? Okay, I put a value in there. What is this tag thing? I can say what's in the name box, and I can save in that I can save the food box text. But what about my movie box text? Okay, so if I go ahead and I do a store value, and I plug that in there, what's the problem if I store what's in name box as name box text in movie box text? Let's take a look and see what happens. So we're going to do this. We're going to start this off. So favorites.db.StoreValue, and I'm storing it under namebox.text. I'm going to stay to the food box, and then I'm going to store it at namebox.text. I'm going to store the movie box. So we're just going to do this to test it out. We've got our app over here on our emulator, and I'm going to type in Cody, and my favorite food is Szechuan, and my favorite movie, I want to watch this one again, and I'm going to hit submit. Okay, now nothing happened, right? We didn't see, we can assume that the submit button.click worked right here, that something occurred, but we don't know what happened. So we need to actually now have something, we want to verify that something occurred with this, and so we need to add a new thing here. So what I'm going to do is we're going to go ahead and go back into our design window. We're going to add a new label, and we're going to call this results label. And we're going to set it to be invisible, or it's now called hidden. That's one of those lovely new changes they were talking about. And we are going to have it so my results label will show what's inside the database. So we'll go back to our code blocks editor, and we're going to go back to my favorites DB, and we're going to .get tag or get value. And we're going to go to results label and set result label.text to this .getValue. And what is the tag we put that in? Namebox.text. So now, when I click on the button, it's going to store my food box, my movie box under my name box, and then it's going to put it as the label of my results label right there. We want to make sure we can see it too, so let's go to result label.visible. And we'll set that to true. Okay, so name again, Cody. Type that better. Favorite food, we'll do Indian since that's what I'm cooking for dinner on Saturday. And favorite movie, we'll do Deathly Hallows, just to make people happy. Part 2 though. And I'm going to, I only have Deathly Hallows Part 2. What happened to my food box and my name? The only thing it's stored is it's stored in that last value I put in there inside that one thing. What a TinyDB is, and this is really key, a TinyDB is a key value storage system. And a key can only have one value. So the key on that was my name box text. And so when I stored the food box, that was great. And then when I said, oh, I'm going to store a movie box, my food box went, it's tossed out there. It's in La La Land. And I only have my movie box now.
So we need 3.
3 separate DBs would be a really, really bad idea. It would work. What's the problem with having 3 databases? Possibly a lot of space, especially if we're storing more than just, like, say, for example, a single text value. When we're using a TinyDB, we have to change our structure. We have right here only stores one single value. But we have a way in AppInventor of holding lots of values in one value. It's not quite as cool as regular code, but we can do it. And what we're going to do is we're going to go over here to built-in, and we're going to go to lists. And we're going to use the make a list. And we're going to put things in a list, and then we're going to put that list in the database. So we're going to take this right here, take all that out, and we're going to take that out here, we're going to take that out here, and so we're going to put inside this, we're going to put my name box, and we're going to put my food box, and we're going to put my movie box. And that is now a single item. It is a list that has my name, my food, and my movie. And I can still store it by my name. Now I have a name box that's storing as the key for my database. My value is now my name, my food, and my movie. Cody, Indian, Deathly Hallows Part 2. So it now stores all of them based on what I have used with it. So to use a TinyDB, we use our store value that can hold one thing. Just one. But if we want to hold a bunch of different things, make a list. Now, can you only hold text in a list?
No.
I can hold a picture. I can have a background picture, and I can put the background picture in the list. I only want to get my favorite movie when I click on the button. GetValue gives me that entire thing. It's a whole list. So if I want to get just one thing out of that, I'm going to go back over to lists. And I want to do select list item. My list is that GetValue. I want what's at position 2. I'm going to click on the button, and I want to set my label text to the second thing in my list.
2.
When we count in AppInventor-Land, we start at 1. When we count in Programming Land, we start at 0. I'm going to take that out. I'm going to take that out. And I'm going to take that out. I'm going to type in Cody. Close that back down. And what should it show? What happened? I just tried to store 2 different values, so I just overwrote my favorite food and my favorite movie with nothing, because I deleted it all out. If I want to find from the database, I should maybe do that as a separate button. And we'll make another button. So when I click the View button, large error, cannot do this. I can't just dump the database into a text field. A database is a huge thing. A text box understands one thing. Text. If I want to get everything in that's in that database, I'm going to have to go through the database. I can take this right here. I can copy this and I can paste this. But watch what happens. View DB contents. Bad arguments to select list item. Empty string. There's nothing there. I can't get a nothing. I can only get the stuff that is supposed to be there. All we know is if we just put something in. And so this is where the database has some major limitations. So we need to actually keep track of stuff. And then we can do it. I can make a variable. And it's going to be blank. And we're going to call this last entry. And I'm going to set last entry to namebox.text. Now, that way there's at least something in there. And then instead of this, because it's going to go to list item, and it's going to get the value that's in the favorites database at weird conglomeration, and it's going to get the second thing there, which should be visual. Yay! When I click on submit button.click, to make this so it's a better database, so we can actually find information, we want to go ahead and find a way to store that in there. So we're storing our entered name into namebox. That namebox value, we're storing it into a variable, so we can then pull that up so we know that we can automatically get something out of that. And that variable name is then set for that. And that sets that variable as the new value for the screen. And we add that in there, and we can go ahead and we can then pull it up. We can't simply just pull up every single value in there. And so the way the database is set up is we can't just loop through it automatically. We can, however, if we store this, say, for example, we store it on a number, and we make that number go up by 1 each time, we could then get what's at whatever number it was at last time. And then get the one before that, the one before that. So if we make as its tag or its key, we make it something that's going to be unique and individual, like say a number, and you can't repeat numbers, then we can make it, oh, that's going to go in, that's first 1, then 2, then 3, then 4, then 5. And we'll store at tag 1, we'll store the name box, food box, movie box. At tag 2, we'll store a name box, food box, movie box. And we increase that number each time we click on the button, and then have it go up by that. And that would be a better way of storing this, because that way we know exactly how big our database is, and when we can take things out of it. And so what we could do with that is we go ahead and we go to make a definitions and say enter name. Instead of a text, it's going to be a 1, 2, 3. And we're going to start off at 1. And instead of setting entered name.text, what we did right here, to namebox.text, we do equals 1. Actually, want that plus. And we're going to change that from entered name to current row. We're going to set current row equal to current row plus 1. So it's going to say that's, and that'll keep track of how many current row is. Right? And so now, instead of store it with namebox.text, our tag is going to be current row. So when we, I want that to be after though. Move over to that way. So it'll store at current row, start at 1, it'll make a list of the name, the text, the food, and it'll then show the results of label current row. So that will then show all of them at 1, and then all of them at, and all of them at, and all of them at 4 each time. Now we can go through this, and we could change the result text, so we could have inside this, actually we can put that still in there, and we can go to set the current label for, we're going to go into my built-in and then control, and we're going to do while test do, and while, and we're going to test is going to be math, and it's going to be number, and 0, and greater than, and in here we're going to put current row. So while test, well, current row is greater than 0, we will set, and so current row.
You have that less than.
Yeah, it's a less than.
Set current row to current row minus one. Okay, so now I'm teaching a couple things here with this. We'll go over it more later in just a second. While current row is greater than 0, I will set the result table to the value of what's at current row at position 2, subtract it by 1, and then do it again. So here's a quick one on the loop. So now when I click on that, it'll show everything that's in there until current row goes down to 0. Which is actually, we should probably not use current row for that. We should use a different number than current row. So let's do definite built-in definition variable, and this is test or database count, data count, escape, data count as current row. Yeah. Escape. Delete. No. 0. And we're going to go to my definitions, set data count to current row. Plug that in right there. And instead of current row, delete that. Yes. And do data count. And set this to data count. So we want to go ahead and actually be able to retrieve information from this at once. And so we need to actually find a better way of storing the data. To store the data, we are going to use a key or a tag of a number. and only that number will be the associated value when we put that in. And so every time we enter information, the number will go up by 1 each time. So we know that we're ready to go to the next row in the database. Because a TinyDB is a flat file type of database. It's very, very basic. It only holds one key, one value. So it's basically like you take a regular piece of lined paper and you write a number 1 and then you write the answer over there. And you write a 2 on the next line, and then after that little double line section, you write the answer over there. And so we're going to go over here and we'll set that visible to true so we can see it. And we'll have what's going to go on that result label at text. We'll put our current row, so that says, okay, that was the value we just put in there. And then we're going to set the current row value to go up by 1 so we can then show that we're going to the next value. Then we have our view button click. This is so we can actually look at what's inside our database. And so when we view this, we're going to go ahead and we're going to go to data count and we're going to set it to current row -1. And we're doing -1 because current row is adapted so we can go to the next row. So we have to go back 1 so it goes to the last row we just put stuff into. And then we're going to set our results visible to true. And then while our data count, so while we have data, it's greater than 0, so as long, however many we have until we're at 0, because we don't want to be at 0, we're out of there, because AppInventor starts counting at 1. We're going to set the text to what's inside the text box already, and then we're going to go and get what's inside at the value at data count at their second position as well. And so we're going to keep it so it'll build up on it, build up on it, build up on it. And then we're going to take data count and go down by 1. So it'll loop through until it's done and put it on the screen. And so if we go ahead and do that, we look over here at our emulator and we click on the view database contents, and there's all the stuff that's in there, and it keeps going through and doing it, adding the whole thing over and over and over again. Isn't that great? It's fantastic. Not quite what we're wanting to do, because we just want to just put it up there once. So we're going to go ahead and we're going to have to clear this all out a bit. So we'll go ahead and reconnect the device because we're done with it. That's okay. Wait for that for a bit. Well, that does that. We're going to go and make a couple changes here. So we're using the join thing. Join is in text. It's a way of putting text together. We're going to get a different one, though. We're going to use the make text. And make text is a little bit cooler. And so we're going to take the results text in there. And hey, look, another one pops up. And we're going to put another text value in there. And that text is going to be a new line. And then we're going to put what's in there. And we'll go and curvy likes American. And curvy likes Inception. I'm just going to do ink. And Nathan, Josh, H, Mexican, Chinese, and American. That \n makes it so it goes to a new line each time. We now have our database. We can see that we actually stored stuff in there. Now, the reason we don't actually see that stuff come back when we reset the app on the device is because when we're actually using AppInventor, it doesn't really install the app yet.